Hello once again. In this video we are going to look at the processes that are involved in redox reactions. So the first thing that we're going to look at, we're going to discuss how to calculate or how to determine the oxidation number of a species in a that's involved in a bond. So if you have how to determining determining, that's an I, determining the oxidation number of a species, right? How do we do that? First things first, we need to understand that the processes of redox, what do they involve? They involve the change in the oxidation number of a species from one charge to another. And so now what is meant by the oxidation number? The oxidation number is the real or the oxidation number is the real or apparent charge. Real or apparent charge that a species has. And so with these charges, they can be positive or they can be negative. So now if we have something like magnesium oxide, right, and then you've been asked to determine the oxidation number of the magnesium in magnesium oxide, you need to be able to do that. And in order for you to be able to do that, you would say, okay, let your unknown species be X, and then the one that you know, you would add that into the equation, and then you equate it to the net charge of the substance that's been given to you. So our unknown charge is the magnesium, but we do know that the charge of the oxide in magnesium oxide is -2, so it's plus -2 is going to give you a net charge equal to 0. So when you then solve for x, what you're going to get is that your x is equal to +2. When you transpose that -2 to the other side, becomes a positive. Hence we can say that the charge of the magnesium in magnesium oxide is +2. Another example, if you have something like SO2 and you're asked to calculate the oxidation number of the sulfur in SO2, how would you do that? The same way as we did it up there in magnesium oxide. So your sulfur is the unknown plus, but now we have two oxides, so plus 2 times -2, the net charge of this species is equal to 0. So we then work out the value of x. Is x minus 4 is equal to 0, and x is going to be equal to +4. Take note that we indicate and we show the charge that the species is carrying. So if we've got something like SO4 2-, that is the charge of a sulfate ion, and we want to know the oxidation number of the sulfur in that sulfate ion. So how are we going to do it? The same way, we know the same way that we use. So we say our unknown is x plus how many oxides do we have? We've got 4 of them. 4, and each one having a charge of -2 is equal to -2, which is the net ionic charge that's been given, the 2- there. All right, and therefore what we are going to then have is x minus 8 is equal to -2. And is equal to -2, and so we will solve for x. X is equal to -2 plus 8. It's going to be equal to +6. So the charge of the sulfur in the sulfate is equal to -2 +6. Another example of how to do that for if we've got something like the thiosulfate, right? and we want to calculate the oxidation number of the sulfur in that ion. What are we going to have? There are two sulfurs, but we don't know their charge, so it's 2x plus 3 times minus 2 for the oxide to give you a net charge of minus 2. Right, so we then work out the value of x minus 6 is equal to minus 2, so 2x is going to be equal to, we transpose the 6, it becomes a positive, so 2x is equal to minus 2 plus 6, so it's going to be equal to plus 4. Then you divide both sides by 2 and we are going to get plus 2. So the charge of the oxidation number of the sulfur in the thiosulfate is going to be equal to plus 2. Right, so for practice you can actually do the following for yourself. Cr2O7, we want to know the oxidation number of the chromium in dichromate or in the chromate ion, and then chlorine in the chlorate ion, and then KMNO4, that Mn, and then K2MnO4, and let's have another one, MnO4, MnO3, right? And then you can work out that. Yeah, that's the one that we're looking for, and then from there you can work that out. All right, so this you shall have for some practice. Just pause the video for now and see if you can solve it, and then afterwards I'll give you the solution. Right, now the solutions to these questions, this is what you should have or you should have obtained. I will just quickly run through that. So for the dichromate, so your chromium, so it's going to be equal to 2x minus 7 times minus 2 is equal to minus 2, so it's going to be 2x minus 14, 2x minus 14 is equal to minus 2, transpose it becomes plus 14, so it's plus 12, so 2x is equal to plus 12, divide both sides by 2, and therefore your x is going to be equal to plus 6. And then the next one, the chromium in chromate is also going to be equal to x plus 4 times minus 2 is equal to minus 2. Transpose that minus 8 to the other side becomes, so your x is going to be equal to plus 6. And then in your chlorate, so the Cl O3 and the charge minus 1, so it's x plus 3 times minus 2 is equal to minus 1, and then your x is going to be equal x minus 6 is equal minus 1, transpose it becomes plus 6, so your x is equal to plus 5. And then your permanganate in KMnO4, the potassium is in group 1, so its oxidation number is 1, plus X plus 4 times minus 2 is equal to 0. So your 1 minus 7, or 1 plus minus 8, so it's going to be equal to 1 minus 8 gives you minus 7, so its X is equal to plus 7. And then K2MnO4, right, again the solution is going to be 2 plus X minus 8 is equal to 0. 2 minus 6, 2 minus 8 is minus 6, so your X is going to be equal to plus 6. And then in MnO2, so what's going to be the oxidation number of the manganese? It's going to be equal to X minus 2 times minus 2, X minus 4 is equal to 0, so your X is going to be equal to plus 4. Thank you for watching the video. If you liked it, press like, share, subscribe, and we'll see you in the next video. Thank you for watching.